वेलकम। हम हमारी समाकलन गणित की सीरीज को आगे बढ़ाते हुए आज देखने वाले हैं गामा फंक्शन एंड उसकी कुछ प्रॉपर्टीज। कल हमने देखा था बीटा फंक्शन एंड उसकी कुछ प्रॉपर्टीज। ठीक है, तो शुरू करते हैं गामा फंक्शन। व्हाट इज गामा फंक्शन? So any function in the form of this integral 0 to e to the power minus x to the power n minus 1 dot dx, it is called gamma function. It is denoted by gamma n. Okay, this is symbol of gamma function where n belongs to natural number. Now it is also called Euler's second integral, as known as Euler's second integral. Now, do you know the Euler's first integral? We have seen in the last class, that is beta function. Okay, now we will see recurrence formula for gamma function. Recurrence formula for gamma function. What is recurrence formula? Nothing but if we have the value of n, we will deduct the value of n plus 1, n plus 2, and so on. Okay, and we will generalize it. It is called recurrence formula. Okay, so now we will find the value of gamma n plus 1 first. So we will rewrite the upper gamma function. What is our gamma function? Gamma n nothing but 0 to infinite e to the power minus x to the power n minus 1 dot dx, where n belongs to natural number. Okay, so I will put n plus 1 in the place of n. What will I get? 0 to infinite e to the power minus x to the power n plus 1 minus 1, that is n dot dx. Okay, now we will apply integration by parts. So we will get x to the power n e to the power minus x n minus 1, that is, we can write this out of this box. Now we will apply the limits 0 to infinite minus integration 0 to infinite differentiation of first function, that is n x to the power minus 1 integration of second function e to the power minus x n minus 1 dot dx. Okay, you know this formula because you have read it earlier in 12th class. So now we will apply this limit. So what we will get, this is infinite, so we will get, if I apply the minus infinite limit on the this function, we will get 0 because e is greater than 0, and if e to the power minus n, that means 1 upon e to the power infinite. Now e to the power infinite will be 0 because e is greater than 0, so this whole function will be 0. Okay, now if I put the lower limit on this function, we will get now this 0, because if I put 0 on the place of x, we will get 0. Okay, minus, I can write out of this box this integral infinite. Now this minus and this minus will cancel out this, so I can write plus. Now x to the power n minus 1 e to the power minus x dot dx. Now see carefully, this is our nothing but gamma function. Okay, so I can write n plus 1 gamma equal to n, and I can write root infinite e to the power minus x to the power n minus 1 dot dx, and this is nothing but the gamma function. So I can write here what we get, n plus 1 will be n gamma n. So this is our recurrence formula. Now where n greater than 0. Now we will see one result. After that we will generalize this formula. Okay, so first see the, we will prove a result, that is gamma n plus 1 is equal n factorial. How we will prove this very result with the help of this formula. So suppose first I put n equal 1, okay, in the gamma function. So what was gamma function? 0 to infinite e to the power minus x to the power n minus 1 dot dx. Okay, so if I put 1, what will I get? 0 to infinite e to the power minus 1, sorry, uh, minus x to the power 1 minus 1, that is 0, and simply remove it because it will be 1. Now dx. Now after integrating this function, what we will get? Minus e to the power minus x integration 0 to infinite, and this value will becomes minus infinite, that is 0, 0 minus 1. Okay, so what will we get? 1. So we can say that the gamma 1 equal 1. Okay, suppose this is equation 1. So if we, now we will find the value of gamma 2. Okay, so I can write 2 as 1 plus 1. Okay, but here if I use this equation that we have proved earlier, this equation, okay, so I can write the value of n as 1, then we will get n plus 1, that is 1 plus 1. Okay, so suppose n plus 1 equal n gamma n. We have proved it earlier. Okay, so I put, suppose this equation second, so I will put n equal 1 in equation second. What will I get? N equal 1, so I will get the value of 2 equal 1, that is 1 gamma 1. And what is gamma 1? That is 1, so I can write it as 1. Now if I will write n equal 2 in this very formula, so I will get the value of gamma 3 is equal to 2 gamma 2, that will be 2 dot 1, because the value of gamma 2 is 1. Okay, now if I put n equal 3, what will I get? The value of gamma 4 will be 3 gamma 3, that nothing but 3 into, what is gamma 3? 2 into 1, 2 into 1. And if I write n equal 4, I will get the value of gamma 5 will be 4 gamma 4, that is 4 into gamma 4. What is gamma 4? 3 into 2 into 1. I am not solving it because this is our equivalence formula, and you can easily see that this is in pattern. Now we will generalize these results. Okay, so gamma n plus 1, and what will be the answer? Let's, we will observe here. If I put gamma, sorry, n equal 1 in this uh, equation, that is equation number second, what I get? N plus 1. Okay, that is 1 plus 1. If I put n equal 1, 1 plus 1, that is gamma 2. Now gamma 2, that is 1 gamma 1 because of this result. Okay, now we will find the factorial 1. As the we put n equal 2 in this equation, that gamma 3, what will you get gamma 3 as? 2 factorial. This is nothing but 2 factorial. This is nothing but 3 factorial. Okay, this is nothing but 4 factorial. Then we can deduct that gamma 2 is 1 factorial, gamma 3 is 2 factorial, gamma 4 is 3 factorial, and gamma 5 is 4 factorial. That gamma n plus 1 will be n factorial. Okay, this is simple observation. Now we will move ahead. Now we will prove a standard integral. After that we will call it a day. Okay, so we will see now standard integral. What is standard integral? First see, we will prove that 0 to infinite e to the power minus ax x to the power n minus 1 equal gamma n upon a to the power n. Okay, we will prove this formula. It is very simple formula because we will prove it using the definition of gamma function. What is definition of gamma function? Nothing but 0 to infinite e to the power minus x x to the power n minus 1 dx, where n belongs to n. We will put ax, no, sorry, any variable, suppose ay at the place of x. So what will you get at the place of dx? A dy. Okay, let's put it in gamma function. So gamma n will be 0 to infinite. Limit will be same because a is a constant. Okay, if I put 0 at the place of x, I will get the value of pi as 0. And if I put infinite, I will also get the value of pi as infinite. Okay, so limit will be not changed. We will only change the variable. So now what I write at the place of x? Ay. Okay, dot ay to the power n minus 1 dot a dy. Okay, now a to the power n minus 1 integration 0 to infinite e to the power minus ay y to the power n minus 1 dot a dy. So I can, we will solve it in the next step. A dy. Now we have 1 power of a and here n minus 1, so I can write it simply n 0 to infinite e to the power minus ay dot y to the power n minus 1 dot dy. So here left hand side we have the gamma n, so I can write gamma n upon a to the power n equal 0 to infinite e to the power minus ay y to the power n minus 1 dot dy. We have proved this very formula. We can change this variable to x because if I write x equal y in this formula, the result will be same. It is very basic property of integration. So we have proved this formula so far. Now we will see in the next video the relation between gamma and beta function, and also some other properties of beta and gamma function together. So until then, see you. Thank you.